Okay, so I'm going to talk a little bit about the absolute value function. Okay, it looks like this: y equals the absolute value of x, and when graphed, it kind of has a V shape, V-looking shape. Okay, so just to go back a little bit, absolute value refers to the positive distance from something to zero. So on a graph, this is what this will look like. Pretty much this line that used to be here, if you remember that as y equals x, okay, a long time ago, all our negative counterparts, so all of the negative y values kind of got flipped up this way because what used to be negative is now positive. So this piece right here is now everything up here where y is also positive. Okay, so that's what it kind of looks like, a little bit of background information on it. Some of the properties for this, can we do this in a different color, is that we have a vertex at 0, 0, or the origin, however you want to think of it. Okay, the vertex is also known as our minimum in this case because it's the lowest point. So this is also a minimum, a relative minimum if you want to be more exact. Okay, and it also has a slope of 1. So if I pick 2 points, say like this point here and this point here, if you remember, slope is rise over run. Okay, so rise over run, side note. Okay, this is equal to our slope. So from here to here, I rise 1 and then I go over 1. So my slope is 1 over 1, which is just equal to 1. Okay, and this is just the rate at which the graph is increasing. As x increases, y is increasing 1 over 1. Okay, so another thing about this graph is we have a domain and range, of course. And the domain for this one, if you look at it on the left side, we're going to forever, which is actually negative infinity. Okay, so let me use my colors for this one. So on this side, we're going to negative infinity. And on this side, we're going forever right, which is positive infinity. So my domain for this is actually all real numbers. So I can write this way: negative infinity to infinity with parentheses because we cannot reach infinity. Or I can use my other notation that we've been doing in class: x belongs to the real numbers. If you want to use set notation, we would do x such that x belongs to the real numbers. Okay? The range for this graph, again, let me use my colors here. The range for this graph is not all real numbers. I know a lot of people like to, the minute you see all real numbers, you want to put it for both of them. However, in this graph, range is not going forever down. So if I look at my lowest point, okay, it's here at the vertex. So my lowest point on y, because remember y is my range, is actually going to be 0. Then if I go up, well, yeah, again, my highest point will be infinity. So I can say that my top number here will be infinity. Okay. The range is going to have a bracket here for 0 because there is an actual point there. And if I wanted to write this algebraically, I could say that y is greater than or equal to 0. Likewise, set notation, I would say y such that y is greater than or equal to 0. And remember that y belongs to the real numbers. Okay, and that's pretty much our parent function for absolute value. In the next video, I'm going to go ahead and talk about what happens if I move this vertex. So if I change the slope. So several things can happen. I can move this location, I can make this steeper, I can make it wider, and that does have effects on these things I have over here. Okay, so hopefully this was enough for the introduction.